Close your eyes. Picture the Big Bang. Go ahead. Really picture it. I know what you're seeing. You're seeing a dark, empty void, infinite blackness stretching in every direction. And somewhere in the middle of all that nothing, there's a point, a tiny, impossibly dense speck. And then it explodes. Light, matter, energy, everything blasting outward like the most violent bomb in history. Debris flying in every direction, expanding into that dark, empty space, filling it up, cooling down, eventually becoming stars and galaxies and planets and you. That's what you've been carrying around in your head since middle school, since the first time someone told you about the Big Bang. A cosmic explosion, the ultimate firework. Here's the problem. That picture's wrong. Not a little wrong. Well, it's simplified, but basically right. Wrong. Fundamentally, completely, structurally wrong. And I'm not saying this to be dramatic. I'm saying this because that image in your head is actively preventing you from understanding what actually happened. It's not a stepping stone to the truth. It's a wall. Every time you try to think about the origin of the universe, your brain pulls up that picture, that explosion in empty space, and you're done. You can't get past it. You'll ask questions that don't make sense. You'll expect answers that can't exist. You'll feel confused, and you'll think the confusion is because the physics is hard, but it's not. The confusion is because you're starting from a broken image. The word explosion is the problem. Someone, at some point, decided to describe the origin of the universe using a word that means a violent expansion of material into surrounding space. And that word, that one word, infected everything. It shaped how you think, what you imagine, what questions you ask. It's a metaphor. And like most metaphors in physics, it's not just imprecise, it's misleading. It's pointing you in exactly the wrong direction. So before I can tell you what the Big Bang actually was, I need you to do something difficult. I need you to delete that picture, burn it. Get rid of the empty void, get rid of the little speck, get rid of the explosion, all of it. Because where we're going, none of that applies. And if you drag that baggage with you, you're going to be fighting me every step of the way. Ready? Good. Let me show you why the explosion picture can't possibly be right. Think about what an explosion actually is. A real one. A bomb goes off in a building. What happens? There's a specific point where the detonation occurs. A location. A spot you can point to and say, there, that's where it happened. The blast expands outward from that point into the surrounding space. Shrapnel flies in every direction, moving through the air, through the room, through the building. The debris travels into pre-existing space that was already there before the explosion. The room existed before the bomb went off. The air existed, the space existed. The explosion just filled it with energy and debris. Now apply that to the Big Bang. Where did it happen? Point to it. Which direction in the sky should I look? Up, left, towards some specific constellation? You can't answer that. And it's not because we haven't found it yet. It's not because we need a bigger telescope. It's because the question doesn't make sense. There is no location where the Big Bang happened. There was no pre-existing space for it to happen in. There was no empty void sitting there, waiting to be filled. There was no dark room. There was no outside. There was nothing. Not empty space. Nothing. Not even nothing in the way you're imagining it right now, which is probably a big black emptiness. That's still something. That's still space. I mean no space, no dimensions, no coordinates, no here, no there, no anywhere. The Big Bang didn't happen somewhere in space. The Big Bang was space beginning to exist. See, space itself started, not matter flying into space. Space, the very fabric, the very stage you think everything happens on that started. It didn't exist, and then it did. And it didn't expand into something. It just expanded. There was no room. It was filling up. The expansion was the creation of room. Every inch of new distance between things wasn't things moving apart through space. It was new space appearing between things. That's not an explosion. That's something else entirely, something that has no analogy in your everyday experience. And that's exactly why this is so hard to picture. You've never seen anything like it. Nothing in your life has prepared you for this. So how do you picture something that has no analogy? You improvise. You find the closest thing and you use it carefully. Here's what I want you to imagine. You're in a kitchen. There's a ball of raisin bread dough sitting on the counter. Raw dough, raisins scattered throughout it, evenly distributed. Now you put it in the oven. The dough starts rising. It expands. It gets bigger. Now here's what I want you to focus on. Pick any raisin, anyone. Call it yours. As the dough rises, what does your raisin see? Every other raisin is moving away from it. The raisin to its left is drifting left. The raisin to its right is drifting right. The raisin above is going up. The one below is going down. Every single raisin in that dough is receding from your raisin. And here's the critical part. The raisins aren't moving through the dough. They're not crawling or swimming or pushing their way outward. They're sitting still. The dough between them is expanding. The raisins are exactly where they were relative to the dough itself. It's the dough that's growing. New dough is appearing between them, stretching, inflating, creating more distance without anything actually traveling anywhere. Now pick a different raisin, any other one. Make that your new observation point. What does that raisin see? Exactly the same thing. Every other raisin moving away from it. Same pattern, same rate. No raisin is special. No raisin is at the center of the expansion. There is no center. The expansion is happening everywhere in the dough simultaneously. That's the universe. Galaxies are raisins. Space is the dough. The galaxies are not flying apart through space like shrapnel from a bomb. The space between them is growing. New space is being created right now between every galaxy and every other galaxy, not at the edges, not from some central point, everywhere, all at once. And this distinction, galaxies moving through space versus space itself expanding, sounds like the same thing. It sounds like I'm playing word games. I'm not. It changes everything. If galaxies were moving through space, they'd have a speed limit. They'd need energy to travel. The ones at the edges would be the fastest. There'd be a center you could trace them back to. None of that is true. Galaxies beyond a certain distance are receding from us faster than the speed of light. And that doesn't violate relativity because they're not moving through space. The space between us and them is growing that fast. Nothing is traveling. Distance is just increasing. That's not an explosion. That's expansion. And once you see the difference, you can't unsee it. Now here's the implication you've been trying to avoid. If there's no center of the expansion, if every raisin sees the same thing, if the dough is expanding everywhere equally, then there's no center of the universe. None. You want there to be one. Your brain is screaming for one right now. Because if the universe started, if everything used to be closer together, then surely there's a point where it all began. A location, an origin, a middle. There isn't. And this isn't a gap in our knowledge. This isn't, we haven't found it yet. This is a consequence of the physics. If space itself is what's expanding, and it's expanding uniformly everywhere, then every point in space is equally the point where it all started. You right now, sitting wherever you are at the center of the universe. So is someone on the other side of the planet. So is someone orbiting a star 40 light years away. So is someone in a galaxy 1 billion light years from here. Every single point in the universe has equal claim to being the center because the Big Bang happened everywhere, not from a point, everywhere. And I can prove it. Look at the cosmic microwave background radiation. That's the afterglow of the Big Bang, the leftover heat from when the universe was young and hot and dense. It's radiation that was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light to travel freely. If the Big Bang happened at a specific location, that radiation would be concentrated in one direction. You'd point your telescope one way and see it blazing, and point the other way and see nothing. But that's not what we see. We see it everywhere. Every direction, uniform to one part in 100,000. The afterglow is the same temperature in every direction because it came from everywhere. Because everywhere used to be very, very small. The entire observable universe, everything you can see with every telescope ever built, all of it used to be compressed into a region smaller than an atom, not at a location in space, as space. All of space was that small, and it expanded, not into anything, it just expanded. And now here we are, inside it, made of it, looking at the ancient light that's been traveling since space was barely old enough to let it move. And it looks the same in every direction because there is no special direction, there is no center, there is no edge. There's just expansion everywhere, always. Time equals 0.5 seconds / it wasn't. It was the oldest light in the universe, released when the cosmos was 380,000 years old and had cooled just enough for electrons to bind to nuclei and let photons travel freely. That light has been traveling ever since, stretched by the expansion of space from visible light into microwaves, cooled from thousands of degrees to 2.725 Kelvin. That temperature matches the prediction of Big Bang theory to extraordinary precision. Evidence number 3, the abundance of light elements. Big Bang nucleosynthesis predicts that in the first few minutes of the universe, when everything was hot enough for nuclear fusion, but before it cooled too much, protons and neutrons should have fused into specific ratios of hydrogen, helium, and trace amounts of lithium. About 75% hydrogen, 25% helium, tiny amounts of everything else. We look at the oldest, most pristine gas clouds in the universe, gas that has never been inside a star, and that's exactly what we find, exactly those ratios. 3 completely independent lines of evidence: the expansion of galaxies, the cosmic microwave background, the abundance of light elements, different observations, different instruments, different decades, all pointing at the same conclusion. The universe is expanding. It was hotter and denser in the past, and if you run the clock back far enough, everything converges. That's not a guess. That's not a theory in the way people use the word casually, meaning a hunch. That's a theory in the way physics uses the word, meaning a framework that makes precise, testable predictions and has survived every test we've thrown at it. This is measured. This is real. Now here's where I have to be honest with you. And I mean really honest, not the kind of honest where I soften the edges to make you feel better. We don't know what happened at the very beginning, time zero, the moment itself. Our equations, the ones that work beautifully for everything I just described, the expansion, the cooling, the formation of elements, those equations break down as you approach the very first instant. Not because the math is wrong, because the conditions become so extreme, so incomprehensibly dense and hot, that the physics we know stops being reliable. General relativity, our best theory of space and time, predicts a singularity, a point of infinite density, infinite curvature, infinite temperature. And whenever a theory predicts infinity, that's not an answer. That's the theory raising its hand and saying, I don't work here anymore. We don't know if there was a before. We don't know if that question even makes sense. If time itself began with the Big Bang, then asking what happened before, it is like asking what's north of the North Pole. The question has the structure of a real question, but it might not have an answer. We don't know why the expansion started. We don't know what caused the initial conditions. We don't know if our universe is the only one or one of an incomprehensible number. We don't know if the laws of physics had to be the way they are or if they could have been different. These are open questions, real ones. And here's what I need you to understand. That's not a failure. That's not a weakness in the theory. That's the whole point of how physics works. Physics doesn't hand you a complete story with a satisfying beginning, middle, and end. It gives you precise, tested descriptions of what we can measure and honest silence about what we can't. The Big Bang Theory doesn't tell you why the universe exists. It doesn't tell you what came before. It doesn't give you meaning or purpose or a reason. It tells you how the universe has been behaving since the earliest moments we can test, and it tells you with extraordinary precision. That's not incomplete. That's integrity. The willingness to say, we know this, we've tested this, and beyond that boundary, we don't know yet, is the most honest thing a scientist can do. And if that bothers you, if you want a complete story, if you want someone to tell you why there's something rather than nothing, I understand. But I can't give you that. Nobody can. Not honestly. So let me give you what I can. The Big Bang isn't something that happened a long time ago. It's not a historical event you read about, like a war, an earthquake, something finished, something over. It's still happening right now, this second. Space is still expanding. The distances between distant galaxies are growing as you listen to this. Not because those galaxies are racing through space, but because new space is appearing between them, quietly, everywhere, all at once. The expansion that started 13.8 billion years ago never stopped. It's still going, and it's accelerating. The universe is expanding faster today than it was a billion years ago, and it'll be expanding faster a billion years from now than it is today. You're not looking back at the Big Bang from some safe distance. You're inside it. You're part of it. You are the Big Bang, still happening. Every atom in your body was forged in the processes that followed that initial expansion. The hydrogen in your water was made in the first few minutes when the universe was a nuclear furnace fusing protons and neutrons. The carbon in your cells, the oxygen you're breathing, the iron in your blood, those were cooked inside stars that lived and died billions of years before you existed, stars that themselves were made from the material of the early universe. You are ancient matter. You are the debris of a process that started 13.8 billion years ago and never finished. And that debris assembled itself through gravity and chemistry and time into something that can sit here and ask where it came from. That's not just physics. That's the most extraordinary. So stop picturing an explosion. There was no explosion. Start picturing everything, everywhere, stretching, expanding, creating new distance, new space, new room for things to happen. And you, right here, made of the oldest material there is, assembled into something conscious, something curious, something that refuses to stop asking questions even when the answers are uncomfortable. That's what the Big Bang actually is. Not a moment, a process. And you're living proof that it worked. If you want to keep going deeper, subscribe to Feynman Physics. I'll see you on the next one.